Welcome to School of Civil Engineering. As we have started a STAAD Foundation Advanced Tutorial series, and in some previous video I have shown you that how will analysis and design for isolated or single footing and also for combined footing. And in this video I will also show you about isolated footing design, but this is very easy method. By using a easy method I will show you about that procedure. So if you're new here, you can watch the previous video given in description, and about the software download link also given in description. So let's start. First of all, we'll open our STAAD Foundation software. After opening STAAD Foundation software, we'll go for our next work. It's taking some time, and if you think that this video are helpful for you, so you can press the like button, also leave a comment so that I can understand this video is really helpful for you. So after that I'll go here new, and in our previous video I have used General Foundation, but now I will use Toolkit Foundation Toolkit. Okay, so by clicking here open, then wait for some time. Now click on the plus. Okay, click on that plus here, and here you'll find that create isolated footing or block. So click here, and from here you have to select the unit, design code, which design code you want to use, job name, it's isolated job, then default unit you can use English or SI, anything you want. Design code, from here you can select ACI design code, one of them. Okay, I'm just showing you that how will work here. After that you have to decide which code you will follow or what you will use, which unit you will use. So from here you will find that I will use English unit. Then here this is the first step. If you see here concrete and river, you are showing here concrete, you are showing here concrete and river, and here we'll use our concrete properties and river properties. Okay, so here unit weight of concrete I will give here 150. Minimum bar spacing you can change that. You can also change from here the unit required for you. Then minimum bar spacing from here, then maximum bar spacing from here. What will be the maximum bar spacing and minimum bar spacing? Minimum bar spacing and maximum bar spacing, it's 3 inch, 8 inch. I am considering you can change that. Strength of concrete I am considering it is 3 KSI. Yield strength of steel you can also change that. I am using 60 KSI. Okay, footing minimum bar size. Which bar will use in footings? Suppose here I will use 5, and footing maximum bar size here suppose I will use 10. Then pedestal minimum bar size I will use 3, and pedestal maximum bar size I will use suppose 6. Okay, so this is our property for concrete and river. Now we'll click here next, and here we'll use unit weight of soil. You have to give here unit weight of soil. You can also change the unit here. Then soil bearing capacity, here is the bearing capacity. Suppose this is the bearing capacity here given 4 kips per square feet. Okay, take it as default, and before that you have to do that important thing, soil types. Which types of soil here below foundation. So if you think that this is cohesionless soil or cohesive soil means clay soil. Okay, and cohesionless soil means sandy soil, like that. So after here, if you have any searchers, you can give here depth of water table, you can give here. So from depth of water table will be from ground level to depth of water table, ground level to the water table level. Suppose I am giving here water table level are 20 feet. Okay, search charge for loading you can give here. Then question, if you select here question, then you have to give here question. Shear strength, if you have value of shear strength, you can provide here. Bottom clear cover 3 inch. Okay, so this is the cover and soil types. Then we'll again click here next. After that, footing geometry, we have to give here the footing geometry. So minimum thickness, you have to give here minimum thickness. I am considering it's 1 feet or 12 inch. Maximum length 500 inch and maximum width 500. Maximum thickness 16 inch, I mean 5 feet. Plane dimension, you can also give here thickness increment, I mean at which inch the thickness will increase. Offset x direction, here is the important thing, here is the offset. Suppose if your column are middle point of the foundation, that it will be 0 0. Okay, but if you think that your column are some, they have some eccentric, this is it is eccentric column with respect to the foundation, then you have to give here OXD. What do you mean of OXD? OXD is offset x direction. Okay, offset x direction. So if you think that if your column are away from center point of the foundation, then you have to give plus if is it in x direction, and if is it right side, then you have to give here plus value, and if is it left side, then you have to give here negative value. After that, also similar for z axis, also for this is the z axis. For z axis, if I move that, also for z axis you have to give positive value if the center point and center point are above from the center point of foundation, and if below, then you have to give the value is minus, like that. Okay, so I'm not giving any value because I'm considering that our foundation are middle point of the, our column or middle point of the foundation. Okay, and here you can also, they have 3 design type. So calculate dimension, if you select that option, calculate dimension, it will calculate dimension that are required for that design. But you can set dimension, you can also set here, click here and set dimension. Just you have to give here the dimension what you required in x or y direction. Okay, then it will consider it as default, or you can consider a fixed length. If you have length are fixed, then you can give your fixed length, fixed width, like that. So I am giving here calculate dimension, then I'll click here next, and here is the ratio, length with ratio. Suppose if you give here 1, our foundation will be a square shape. You can change that length with ratio. Then we'll click here next. Then you're seeing a pedestal geometry, sliding and overturning. You have to give here coefficient of friction, factor of safety against sliding, factor of safety against overturning, pedestal height here, column pedestal length here, column or pedestal length, or column or pedestal width. This is the length and this is the width. Okay, now if we go next, now you have to give here load. If you have to give here load. So suppose our load will be in negative y direction. Suppose I will consider our load will be like 2000 fy, and our moment will be mx direction or mz direction. Suppose I will consider our moment will be in mz direction, and it will be suppose 40. Okay, and from here we have to select our load, which types of load is it. So I'll consider it is dead load. Then again for y direction, this is the load from directly downward. Suppose if you have load for your column. I mean, when you will use structural analysis by using ETABS or by using STAAD Pro, then you will found the foundation value also for FX, FY, FZ, MX, MZ. Okay, so you have to give here that value, right? You have to give here that value according to, but you have to consider what is in which direction. Okay, what is in which direction, you have to give here carefully. So suppose it will be a -150. Suppose we'll give here now live load, and our moment will be 35, and from here we have to select live load. Okay, we have, and from here you can also change your unit required as your work. So click here next. So from here we have to use load combination. Okay, so for load combination you have to select any code by using which code you want to use load combination. Suppose I am using that, then click here update table, and then also click here update table, and then finish. So now you are seeing that here is our foundation, this is the elevation, and this is the plan of that. So here is given everything. Now we'll go for click here, will and design and analysis. Okay, so here if we make little bit, so here you can select that here is our foundation. Okay, here is our isolated foundation. And if we go here detail and schedule drawing, so here is our detail, here is our our detailed drawing, here is our reinforcement. Okay, here is our reinforcement, and given where is the reinforcement, and here given bottom reinforcement, 17 reinforcement, number 5 17 reinforcement in that direction, in Z direction, and 17 in number 5 17 in Y direction. At our foundation size have selected 9.833 feet, and also it's 9.833 feet. This is the plan. Okay, and from geometric plan we can see that here our detail dimension of that. Okay, and here if we see here, this is the depth of foundation 1.833, 1 feet 10 inch, 20 inch total depth of the foundation is 20 depth. And in that option, toolkit mode, the schedule drawing are not available. Okay, this is only available for general foundation. So in our previous video I have shown you that how we'll design an analysis by using a general foundation. So this is, I think this is very easy to design a foundation, that how we'll design a foundation. And also you can save that by using save as drawing. And if you think that this video was helpful for you, just please press the like button so that I can understand that is really helpful for you. And also leave a comment for any suggestion or for any requirement. And if you are new here, you can press the subscribe button if you think that this channel is helpful for you. So thank you very much. Stay well, stay connected till next video.